In this video, we're going to explore how to build more sophisticated Android apps using Jetpack Compose. You'll learn how to efficiently display data with grid layouts, navigate between multiple screens, pass dynamic route arguments, launch other Android apps using intents, and implement a bottom navigation bar for seamless screen switching. All of this will be demonstrated within the context of a complete pet adoption app, giving you practical, real-world experience with Compose features. Exploring grids and navigation in Jetpack Compose from the Programming Professor. Here's a quick overview of what we'll cover in this video. First, we'll look at lazy grids and how they help us build efficient and responsive lists of visual content. Then, we'll walk through building a pet adoption app from scratch. We'll explore multi-screen navigation and passing data between screens using route arguments. We'll also show how to launch other apps from within your Compose app. Finally, we'll implement a bottom navigation bar to give users quick access to the main screens in our app. Lazy grids are ideal for building scrollable layouts with multiple columns or rows. With LazyVerticalGrid and LazyHorizontalGrid, we can efficiently render only visible items, which conserves memory and improves performance. You can define how items are arranged using gridcells.fixed, gridcells.fixedSize, or gridcells.adaptive. For example, adaptive automatically adjusts the number of columns based on screen width and a minimum cell size. This makes it perfect for creating responsive UIs that look good on both phones and tablets. For more dynamic layouts, staggered grids allow for non-uniform item sizes. These layouts are helpful when you have content of varying height or width, like cards with different amounts of text or images with different aspect ratios. LazyVerticalGrid staggered grid and LazyHorizontal staggered grid provide flexible support for this, and can also use fixed or adaptive sizing to control the grid structure. Once you've set up your grid, it's important to polish the layout using padding and spacing. The content padding parameter allows you to add padding around the edges of the grid, which keeps your UI from feeling cramped. Horizontal arrangement controls the space between columns, and vertical arrangement manages spacing between rows. These simple tweaks can make your grid layouts look much more professional and user-friendly. We'll be applying these concepts in our pet adoption app, which follows a primary detail screen pattern. The main screen displays a scrollable grid of pet images, and when a user taps on a pet, they are taken to a detail screen with more information. This app structure is commonly used in real-world apps and teaches you how to combine layout, interaction, and navigation. To get started, you can download the Pet Adoption Starter project from GitHub. The starter code includes a pet app composable, a ViewModel to manage state, a pet data class, and a data source that loads a list of pets. You'll also find 18 pet images in the project's drawable folder, which gives us enough data to work with a realistic and visually engaging UI. We begin by implementing the list screen composable. This screen uses a scaffold for overall layout and includes our custom pet app bar at the top. The pet images are displayed in a LazyVerticalGrid. Each image is made interactive using modifier.clickable, so users can tap on them to view more information. We also include a preview list screen composable, so we can preview this UI without launching the full app. Next, we implement the detail screen composable. This screen displays information about the selected pet, including name, breed, and age. There's also an Adopt Me button, which is wired to an on-adopt-click callback that navigates to the next screen. While there's also an on-up-click callback parameter, it's not connected to any behavior just yet, but we'll use it later for back navigation. To aid with development and testing, we add a preview detail screen composable that allows us to view the detail screen in isolation. This is especially helpful when you're tweaking the layout or verifying dynamic content without needing to click through the app each time. Then we implement the Adopt Screen composable. This final screen thanks the user for adopting a pet and includes a Share button so the user can tell others about the adoption. Just like the other screens, we provide a Preview Adopt screen so we can visualize the UI before integrating it into navigation. Now let's talk about navigation. Apps often consist of multiple screens for completing different tasks, and users navigate between them using buttons, gestures, or menus. Jetpack's navigation component provides a system for managing screen transitions through a back stack. The screen at the top of the stack is what the user currently sees, and Compose handles transitions between screens using this structure. Jetpack Compose Navigation consists of three main elements: NavController, NavGraph, and NavHost. NavController keeps track of the navigation back stack. NavGraph defines what screens' destinations are in the app and how they're connected. NavHost is the container that displays the current destination. You create a NavController using Remember NavController, define routes using composable functions, and pass that controller into a NavHost to manage navigation. In our pet adoption app, we define a sealed routes class with serializable annotations for each screen: list, detail, and adopt. This allows Compose to convert route objects to and from strings, making it easy to pass data between screens. The NavHost then defines three destinations corresponding to the list, detail, and adopt screens and manages navigation between them. By default, users can go back using Android System Gesture or Back button. But for a consistent experience, we can add an Up button to our app bar. This button appears when a user is not on the home screen. The Can Navigate Back flag controls whether the button is shown, and the On-Up Click callback defines what happens when it's tapped. To implement the actual back navigation logic, we use NavController. Navigate up inside the Detail screen and Adopt screen. This method removes the top screen from the stack, revealing the previous screen. To make this work, we need to wire up the Up button in Pet app so it passes the On-Up Click behavior correctly to each screen. The updated implementation also includes sample code for the Navigate Up functionality and shows how it integrates with both the Detail and Adopt screens. This ensures a consistent and intuitive back navigation experience across the app. Let's look at architecture. Initially, our app used a single view model shared by all screens. This approach works for small apps, but becomes difficult to manage as complexity grows. Shared state across screens can lead to bugs and unnecessary re-renders, and makes testing more difficult. A better approach is to use one view model per screen. This modularizes your logic and makes each screen self-contained. In this new architecture, we have List View Model for the pet list, Detail View Model for the pet detail, and Adopt View Model for adoption logic. Each one depends on the shared pet data source for data, but they are otherwise independent. Each view model now owns and remembers the state of its corresponding screen. You'll create 3 new view model files, one for each screen. List View Model loads the pet list, while Detail View Model and Adopt View Model each provide a method to retrieve a single pet by ID. This structure is clean, testable, and easier to maintain. With the new architecture in place, our composables also change. Instead of passing the entire pet list or pet object, we now pass only the pet ID. Each screen's view model retrieves the data it needs using that ID. This simplifies the UI logic and reduces unnecessary state sharing. The same pattern is applied to the Adopt screen, which now uses Adopt View Model to fetch the pet by ID. This keeps the composable focused on layout and user interaction, while the ViewModel handles all data logic. We also need to update our preview composables. Instead of manually passing lists or pet data, we now pass a pet ID and let the ViewModel handle the rest. This keeps our previews accurate and ensures they reflect the behavior of the actual app. When you need to pass data between screens, Jetpack Compose supports root arguments. You can use @serializable data classes to define your root parameters and extract those arguments using nav_entry.toRoot. This allows you to navigate with structured data like names, IDs, or even complex objects. In the Pet Adoption app, both the Detail and Adopt screens use a pet ID as a root argument. You'll need to update your roots class and navigation graph to reflect this, making sure each screen extracts the pet ID from the root and passes it to the appropriate ViewModel. Jetpack Compose also allows you to start other apps using Android intents. You can use Start Activity with an intent to launch apps like a browser, YouTube, or email. Local Context provides access to the current Android context, which is required to start a new activity. Intents are extremely flexible. You can use them for tasks like dialing a number, viewing a web page, or opening a map. Each intent includes an action and a URI. The action defines what to do, like view or dial, and the URI specifies the data, like a phone number or web address. To make your app more interactive, you can implement a sharesheet using ActionSendIntents. This lets users share messages, images, or other data through their favorite apps like Messages, email, or WhatsApp. You specify the MIME type and data, and use createChooser to display the sharing dialog. We can create a share adoption function to send a message outside the Pet Adoption app. In the Adopt screen, we add a share button that calls Share Adoption. This function creates an intent that includes the pet's name and a short message. When tapped, the user can choose which app to share the message through, making the experience more engaging and personal. Finally, we add a bottom navigation bar to make screen switching faster and more intuitive. Using the navigation bar and navigation bar item composables, you can define icons and labels for each tab. The navigation component manages the back stack, so switching tabs retains state and navigation history. When a user taps a bottom navigation item, you call NavController.navigate with a pop-up to setting to prevent stack duplication. The nav host still manages which screen is shown, and Scaffold integrates both the top and bottom app bars, keeping everything structured and accessible. To wrap things up, we've covered a lot. How to use LazyVerticalGrid and staggered layouts for efficient UI, how to build a full-featured app using the primary detail pattern, how to manage screen transitions with root arguments, how to launch external apps with intents, and how to enhance user experience with a bottom navigation bar. This end-to-end project ties together many core concepts in Jetpack Compose and gives you everything you need to build modern, modular Android apps. Thanks for watching. Let me know in the comments if there are other topics you would like me to talk about. If you enjoyed this video, please like, share, and subscribe for more content on software engineering and technology. See you next time.